Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a typical multiple choice question number 25, asking for pH calculation in topic 8, acid and bases, right? Let's see, right? They're asking for, given 10 cm³ of the aqueous solution of sodium hydroxide, a strong alkaline, pH with 10, okay, is now mixed with 990 cm³ of distilled water. So obviously it's going to be diluted, right? And what is the pH of the resulting solution? Many students, after reading the question, they first recognize an equation that is really useful for handling this question, and that is the way for us to handle dilution. That is the C1V1 equals C2V2. I'm not saying this is a wrong approach, but I would say if then you think of the concentration and switch the pH to the concentration of hydrogen ions, H plus concentration, that is okay, because at the end that will be your C1 and your V1 is going to be 10. You can divide by 1000 or not, because both sides will be divided by 1000, meaning cancelled. And C2 is my outcome answer, and the V2 is going to be 10 plus the 990 divided by 1000, and so you get the C2 and switch back to the pH, right? So that is okay, yeah, because if you do this as the approach, you may realize that pH actually shows you the proton concentration, right? That is going to be 1 times 10 to the power negative pH, right? So that's why in this case negative 10, and so that's why the C1, which is going to be the initial concentration, that will be 1 times 10 to the power negative 10, right? And the V1 will be our initial volume, and that is 10. Again, we divide by 1000 to get dm³, but remember two sides are having divided by 1000, so meaning cancelled, right? So we can be lazy and just eliminate that part. And so C2, and finally the V2. The V2 will be 10 plus the 990, so that is going to be 1000, right? Obviously, you can work out the C2 in hand, some mathematics, and finally take the negative log, then you can probably get the answers, right? But what I'm now wanting to tell you is a faster way to achieve this question, right? Is that remember, apart from learning the first definition of pH, negative log of the concentration of H plus, I think many teachers should have told the student that here comes a really important concept, right? 1 degree of pH change means 10 times of the proton concentration changes, right? That makes sense, right? Because pH is in a log scale. pH is in a log scale. So 1 degree change of pH already means 10 times. So you can say a solution or orange juice with pH, let's say 4, is like 10 times more acidic than a solution or juice with pH 5, right? Because 4 is lower than 5 by 1 degree, so 4 is going to be more acidic than 5, but by 10 times, right? So that's why we are now working with a wide range of proton concentration, but narrow it down to a really small scale, like a linear scale. So this is the real purpose, or like the nature of science, of why scientists develop the concept of pH, right, for easy communication and deliver the so-called acidity, right? So similarly, right, for this case, we should realize that what we are adding initially, I'm starting with 10 cm³, right, which the pH is going to be 10, right? Point this out, right? And what I'm now having at the end, after adding 990s of the water, why 990? It's all because once you add this 990 to the original 10, you suddenly get 1000, right? And so the numbers become so beautiful and easy to understand, right? From 10 to 1000, let's imagine, from 10 to 1000, is it now we are going to be diluting the solution by 100 times, 100 times. So here, maybe I use the blue, 100 times dilution, right? Whenever it's going to be a dilution process, is it the pH will then be moving towards 7. No matter you're starting with acidic thing or alkaline thing, you'll be migrating to 7, because as we learn, 7 is referring water. Water is the most diluted form, right, with no any solute. So that means for this perspective, 10 times will be moving 1 degree, so 100 times will be moving 2 degrees, right? So 2 degrees, right? Because of the log scale, 2 degrees to 7. Because migrating to 7 means migrating to the most diluted form. So meaning that 10, now you move 2 digits. to 7, right? So at the end, you realize the pH is going to be 8. So that's my answer going to be A.